Okay, so ICP, this is Unit 2, Atoms in the Periodic Table. So two separate topics, but they are related. First half of this unit is talking about atoms. First thing is, imagine you're holding a piece of aluminum foil or a sheet of paper or something. So you could use a pair of scissors and you could cut it in half. If you took one of those halves, you could cut it in half again, and you could cut it in half again, and again and again. Each time you end up with two smaller pieces. So with this piece of aluminum foil, can you endlessly divide the aluminum foil? Is there a point when you can't cut it in half anymore? So is there a point where it's no longer able to be divided? Now for us, this probably is going to be limited by our scissors. We just probably won't be able to see or handle the scissors when it gets to a certain size. But this question is an old question, and it goes all the way back to ancient Greece. Ancient Greece. So the common thought of the day suggested that matter could be divided endlessly, and assuming you had the ability to see it and something small enough to cut it, then there would be no stopping point whatsoever. You could do this infinitely, making small divisions forever. The first person to suggest otherwise was a Greek philosopher named Democritus. He suggested that matter couldn't be endlessly divided. He thinks that at some point it has to stop. There's a point where things are so small that you're not going to be able to divide it anymore. He called this point atomos, which is the Greek word for indivisible. But we've never really heard of him. At least most of you haven't. Maybe you heard of a different guy, Aristotle, probably a little bit more important. He disagreed with Democritus, along with most other people, and he believed that things could be endlessly divided. Of course, given the technology and the scientific resources we have now, we know that there's a stopping point. You can't just divide things endlessly. And we even use the word from the Greek word atoms. So what is an atom? An atom is the smallest particle that retains its chemical properties. If you divide an atom further, you would have smaller particles, and these would have completely different properties. Because an atom is the smallest particle that keeps its chemical properties, we say that the atom is the smallest unit of an element. So let's look at the pieces that make up an atom. The general term for the pieces that make up an atom are subatomic particles. So subatomic particles. If you are familiar with the prefix sub, it means below. So subatomic would be below the atomic level, smaller than atomic particles, subatomic particles. An atom is composed of three unique types of subatomic particles, which you've probably already heard of in previous classes: protons, neutrons, and electrons. Each one of these influences the behavior of the atom in some way or another. The first one, protons. These are found in the nucleus, and they have a positive charge. Parentheses, I'll put a plus here. Positive charge. For a given element, every atom contains exactly the same number of protons in the nucleus. So for instance, I'm looking at the periodic table right now. Carbon has 6 protons in its nucleus. Every carbon atom has 6 protons. There's not a single carbon atom in existence that has less than 6 or greater than 6. The number of protons identifies the element. So any atom with 6 protons, we're going to identify it as carbon. The next subatomic particle is neutrons. Neutrons are also found in the nucleus, and these have a neutral charge. Neutral charge. So that means they do not have a positive or a negative charge. So if positive charge was plus, neutral would be 0. In the current model of the atom, protons and neutrons are held together at the center of the atom in a place called the nucleus. Most of the atom's mass is concentrated. It's located in the nucleus. And our third subatomic particle, electrons, are found outside of the nucleus. So a lot of times in chemistry, we want to figure out what is different. Electrons are different because they are outside of the nucleus. Electrons have a negative charge. Another interesting thing about electrons is that they're much smaller than protons or neutrons, about 1,000 times smaller. So if you think of one proton as the size of a basketball, one electron would be about the size of a marble. Very different sizes. In an individual atom, the number of protons and neutrons in the nucleus is called the mass number. And this, we want to be specific. This is for an individual atom. One specific atom. If we had one atom under a microscope looking at it, this is what we're talking about. So mass number is the total number of protons and neutrons. And it's always a whole number. The number of electrons in an atom can change. And they tend to change pretty often. Some elements have electron numbers that change more than others. We'll talk about electrons more in depth in a different unit. A neutral atom, and this is important, a neutral atom where we'll say the charge equals 0, has an equal number of protons and electrons. Remember, every proton is going to be positive, every electron is going to be negative. When these are in equal numbers, we have a neutral atom. All the positives, all the negatives cancel out, and the charge of the atom is 0. The number of neutrons is next. Neutrons may vary within an element from atom to atom. So if I had a few carbon atoms, I might have one with 6 neutrons, I might have one with 7 neutrons. Each specific atom, though, isn't going to change. So a carbon with 6 neutrons is still going to have 6 neutrons later. Atoms of the same element that have different numbers of neutrons. So look at this. We're talking about the same element, different numbers of neutrons are called isotopes. Remember, same element, that means same number of protons. Number of protons didn't change, but some of them have different numbers of neutrons, and that is what we call isotopes.